Welcome, welcome to the final talk today in this room, from Intrusion to Insight, lessons learned from a month-long AWS compromise. But first, I'd like to thank our silver sponsor, Tamoon. Tamoon is a managed cloud detection and response platform that turns CNAP and CSPM alerts into action, fortifying your cloud security fast. Our approach blends purpose-built technology, AI, and expertise for comprehensive cloud security management. And again, this is from Intrusion to Insight, lessons learned from a month-long AWS compromise. Please welcome our speaker, Korstiaan.
Hi everyone, just checking if it works. I think it does. Awesome. Thank you all for still being here. I realize this is, I think, the last one. So thank you all for being here. I'm going to talk to you about AWS Incident Response, some real-life experience that I would like to share with you. So let's go. I don't have a lot of time, so I'll just, if I speak too quickly, it's because I have too much slides. But don't worry, we'll give the slides to you afterward. So who am I? So I'm Korstiaan. I'm from the Netherlands. I started a company 3 years ago called Invictus, which you might have noticed, or not, but it's here as well. What we do is we do instant response and preferably in the cloud. So I started out traditionally with a lot of on-premise investigations, of course, and in the last few years I've transitioned to cloud instant response because I think it's a really interesting field with other companies going there. Incidents will follow, so that's nice, at least for me. I also really enjoy teaching, so I teach for Sense, which you might know. I teach their cloud instant response course and also develop my own course for Microsoft Cloud Instant Response, and AWS is coming, and I do that at like large conferences. So let's go. Who here has read this blog that we've created? All right, awesome, a few. Well, you can go. No, just kidding. There's more. I'll try to add on it, and we're not going to repeat everything, but this was a blog we wrote about an instant response case, and well, today we're going to share some stuff that wasn't in the blog, and also focus a bit more on, well, what can we all learn from that, I guess, as incident responders, or maybe as someone who's internally trying to protect the company. So let's go. The case. So a little bit of trivia, and it's probably very easy for the people here, but how do you think the threat actor obtained their initial access? How did they get in? Who wants to take a guess? Almost. Yeah. So there's a hint indeed. It starts with AKIA. So yeah, it's a long-term access key that got exposed. So the second question is, of course, well, how did they get that one? Well, there's a few scenarios, and for reasons I cannot explain really which one it was. But the three most likely scenarios are stored in environment variables, build config scripts, and inside images that were in a container registry. We couldn't really get to the bottom of this, mainly because the evidence was gone in a few cases, which is not ideal. But we'll get to that in lessons learned. So, but this is the case in a nutshell, and this is the TLDR. So if you didn't read the blog, don't worry, I got you. So they got in via long-term access key. They did some persistency, so they created additional EC2 users, created additional access keys, and also they created IAM policies, which is kind of interesting, and EC2 machines for persistency reasons. When they did all that, they went on to SES, so awesome talk a bit earlier on SES. They will get another shout out. It's a very popular service for abuse. They also used Route 53 to create hosted domains. So you can use Route 53, as you might know, to host phishing pages or normal pages. Ultimately, the threat actor wasn't really satisfied with the sending limits of SES, so they're like, I want to send more spam and more phishing stuff. So how do you do that? Well, you open a support case. That's what they did. Well, that resulted in ultimately their downfall because AWS got a bit suspicious by their responses. And that's when the client was like, well, we don't even use SES. And then they said, well, you do now. Let's investigate. And that's when we got in. So that's sort of the TLDR. But there's definitely more. So SES is a juicy target. It's very popular because you can send a lot of phishing mails and spam mails, and they have quite a good reputation, the emails themselves, so they'll get past some email security products. So Permiso also wrote a great blog on this, Unit 42, Sysdig, that was just here. And in blue, I have some calls from CloudTrail if you see those two in your environment, there's probably someone that has his access key leaked because they're trying to enumerate. Are there any identities that we can use inside SES, so emails or domains, to send emails? And what's the quota? So how much can we send at once? Which is really interesting for them. Most of this stuff that we see, also in this case, is scripted. So they'll just scour the internet for keys, and then when they find them, they'll run a bunch of enumeration or discovery commands, and if it works, they'll move forward. So they moved forward because the access key was pretty powerful. It had administrator access permissions, so that wasn't ideal for us or for the client. So what it is, and these are all actual events from the case, they are a bit censored for obvious reasons, but you can see here that there was a request to create a user with the username dangerdev@protonmail.me. That's the reason for the title. So they created the user, and similar to what someone else already mentioned is they do like the GUI, so they also created a login profile, so then they could do stuff through the management console, which makes it a bit easier, I guess, for them. So that is where they started out with. They created a bunch of users, and then they created a very small EC2. So it's like a very small instance type, so not very useful for crypto mining stuff. And our theory, it was more for backdoor purposes, because what they did, and you'll see that in this event, it is an event, and it says, oh, it's called Authorized Security Group Ingress. So what this does is basically it allows external access through RDP from anywhere. So let's say we kick out the attacker through their users and their access keys, they could still get in directly via the EC2 machine. Pretty interesting, still not very unique, I think. Then they started to do crypto mining. And they requested the P316X large, which is very expensive, I can tell you that. It is part of the machine learning offering. Luckily for the client, they got really lucky with this one, is you can see it in the error message. There's a limit in all AWS accounts on how many CPUs you can use by default, and unfortunately for the threat actor, this one was above the limit. So when they created this instance, it was actually denied. Not because the client noticed it, but AWS said, well, it's a bit too much, so we're not going to let you spin up that machine. So the lesson here is for the threat actor, don't be so greedy and go a little bit lower. I'm not sure they're listening, but oh, whatever. The interesting part, so this was all sort of what we've seen maybe before, maybe you've seen this before as well. There's some stuff that I think was pretty unique around service discovery, some weird services, or at least for me. Persistence, so they used IAM roles, which was really interesting for external access. Defense evasion, so they went through quite some lengths to sort of blend in and, or at least not stick out too much, even if we'll get to that. So they used similar IAM names as normal IAM usernames. They used policy names that are really similar, and they also were looking at guard duty findings, so they were trying to figure out, well, are we detected? Spoiler alert, they were, but no one was looking at guard duty, so doesn't really matter. Then they performed privilege escalation, and that is, it was really interesting. That was through the IAM policy simulator, and we'll have some examples on how that worked later. And for impact, what we already discussed, they created payment website, or they tried to impersonate payment websites for, most likely for financial fraud, etc. And they interacted with AWS support, which is, I think, also pretty unique for threat actors, or maybe not, but I haven't seen that before. So yeah. Let's go. Service discovery. Another trivia question. Who here, or maybe online, I cannot see you, I cannot hear you, but you're also there. Who here has heard of Amazon Pinpoint SMS? Wow, this is more than I expected. I have never heard of this until this incident, but apparently it's a service that you can use, well, the name says it, to send SMS messages, and they were pretty interested in that. So they were trying to figure out what can we do with this service, and these are all the events that we saw. Interestingly, this was all done through the management console. So they were actually clicking around generating these events. So trying to figure out what are the limits, what can we do, what are the phone numbers, if any, that are associated with this service that we can use for, well, most likely SMS spamming / phishing. Then they moved on to something that is, I think, a bit more common. I've seen it before, where they use SNS, the simple notification service, which also can be used to send out SMS messages and text messages. So. And then last but not least, RDS, so their database offering for AWS, and they were looking specifically for snapshots, which I think was kind of interesting because I'm not sure why they did it, maybe just to figure out if they could grab data directly for exfiltration purposes and maybe like a ransom style attack. But that's the discovery pieces we saw, which are pretty unique. as I mentioned, for persistency, this is what they did, and this is my drawing. So on the right-hand side, we have a victim account. They created an IAM role, and they gave it certain permissions, and then they established a trust relationship with an external AWS account. So we were like, when we were investigating this, we were like, whoa, okay, what's this account? We're like, this is some internal stuff, right? And apparently, not internal, but another AWS account for this client. But apparently, there was an external AWS account belonging to the attacker. So this is pretty interesting as well, because IAM roles and cross-account access is not very unique or super advanced, but I don't think we see it that often, or it's not been reported often that attackers abuse it. I'm not sure why not, because it's really easy, and it works really well. Because what you can do, from an attacker perspective, if you kick out all the access keys that they use, all the users that they use, all the EC2 machines they used, you can still access through this assume role operation directly with the associated permissions that are for this role. So a really interesting technique. I don't want to give away any ideas for attackers, but pretty powerful. So on this thingy, they created 2 roles for 2 different AWS accounts. And here the numbers. So if you see any of these numbers in your account, let me know, because you're pwned like you have a problem. These accounts are not good. AWS mentioned or confirmed that these were threat actor accounts. They didn't really specify whether that's directly under control of the attacker or that it was like maybe another company that got pwned and then they moved further, but it doesn't really matter that much, but these are bad accounts. They also did something interesting with the names of the roles. Who can spot the typo for a role? Yeah, it's missing an R, especially for the reserved SSO, because if you probably know, AWS reserved SSO underscore wildcard, whatever comes after, is the naming convention AWS uses. So they try to blend in. The top one is maybe a bit more uncommon, but if you use landing zones, I don't remember, I think there's what the S is not supposed to be there. But so that's the normal role is without an S, for instance. So pretty smart, trying to figure it out. And you can see in the assume role policy document on the right-hand side the external AWS account and the role name. So I censored out the last part, but you get the ID. So pretty cool persistence method for that. So for the attacker, we talked about defense evasion. So they were trying to stay a little bit under the radar. They weren't really calling the who am I of the cloud a lot, so they didn't really make any of the calls like this to figure out what permissions they had, which was kind of impressive, I think, because almost everyone does that. They removed IAM users that they created, so they were discovered at some point, and the client did some actions. We'll talk about what they were. And then they started deleting a lot of their traces, basically, and their evidence. So they removed their IAM users. They did test user policy, deleted them. They deleted their additional access keys that they added. And they looked at the findings, as I mentioned. And really interesting, we'll talk about it in the next slide, Lightsail. They used Lightsail for some, I guess, backdoor access as well. And they blend in with common usernames. So you can see here on the right-hand side is that they created a user called SES. But this is not a user that's normally created for SES. But if you do use SES, it will create a username called SES underscore and then some random digits. So this is sort of an attempt as well to blend in. So I was pretty impressed by this. It's pretty, I think, interesting. Anyway, for defense evasion, as I mentioned, the client noticed that something was wrong. So what they did was they immediately started kicking them out a little bit, not completely. So what the threat actor did, they went to the Lightsail service. So Lightsail was a bit different than EC2, but it almost can be used for the same things because you can immediately hire server space even with a lot of specifications and power. So they were discovered, and immediately after they tried to create a Lightsail instance. But again, this failed even. This again was a sort of a lucky break, I think, because you can see in the error message, so the account is pending verification. So similar to SES, there's some protection in there. If you never use the service, it will try to protect you from abuse, which is interesting. So they, again, dodged the bullet there. For privilege escalation, I think this was the most interesting part for us because we really didn't see that before. What they did was they used the IAM policy simulator. So what you can do with it is you can say, can you check for a given policy, am I allowed to make these and these calls? That's what it does. So, and then the tool will say yes or no. Yes, you are allowed or not. But if you think from the attacker perspective, instead of directly, why didn't they just call directly these APIs and their action names? Because if you don't have the permissions, it will get all kinds of access denied problems. And if you have smart defenders, they will start to look for that things and they will get alerted. So this is a pretty cool way to check for a specific policy, are we allowed to run these actions? And I didn't see this before, so when I wrote this down, I was like, oh wow, this is really advanced. And then someone is in the room, found out that this was actually part of a security tool by Bishop Fox called CloudFox. It's part of their module. So yeah, I don't know, that's sort of, maybe they're just script kiddies then ultimately, but still, they did find CloudFox, which is, well, maybe it's not that impressive because it's a really good tool, so a lot of people knew it. But that was cool. So you can see it here. On the top side, you can see the GitHub code. And if you look at the admin action names that it checks, they are exactly the same as the CloudTrail event you see underneath it. So this was literally, well, that's why we figured out that's what they used after the fact. That was privilege escalation. So for impact, they started using Route 53 to create domains that were mimicking, well, as you can see, it's on the slide, PayPal stuff. And they were using small things, you can see it, I don't know if you can see it, but they're using, for instance, the L instead of the I. So instead of, I guess, PayPal International, it says PayPal and then LNTL. So it's a little bit of like tricking the user, yeah. And if you think about this, let's say they were able to, well, they actually did, if they use the pinpoint SMS, SNS, and then SES and Route 53, they can make a nice little attack where they spam people with links, they lead to a domain that's under their control, and ultimately then they can start doing more interesting stuff. However, it was pretty targeted. We saw that they were really targeting certain cryptocurrency employees and high-value targets, so very financially motivated, I would say. And also they were very interested in creating Japanese company/business domains. Do with it what you want. I have no idea why. There's no relationship with my client at all, but yeah, apparently this was interesting for the threat actor. Then the interaction with AWS support. I cannot show you what they said exactly because I think it's a bit too sensitive to share, but this is what happens. You create a case and you say, can you please increase my SES limits? This worked a little bit initially, and then they got back and we said we wanted more and more and more. AWS got suspicious. They picked up the phone actually and went to the number that they have for the technical account manager at my client. And they said, well, are you aware of this? And then that's how the ball got rolling. So they got a little bit too greedy, and then that's where it went wrong for them. Now onto the lessons learned. Things that go wrong, and this is a bit more generalized. It's a bit in this case, but also stuff we see for other AWS specific incidents. Deleting IAM credentials. It's of course ultimately a great idea if you have compromised credentials, you want to delete them. But for investigations, I rather have you deactivate them. It's a bit easy to see what they were, what they are at that moment in time and their context, instead of relying then on the CloudTrail logs to figure out what was the original value for the access key. So it's just not ideal for investigations, but not that big of a deal. This one is more difficult for us if you start removing artifacts. So what we saw is they created VMs and they cost money. So the client was like, we're going to get rid of them immediately. I mean, that's what they started with. Before we were involved, I must say. And then they deleted the VM. So we never got a chance to figure out exactly what did they launch on the VM. Well, we can sort of guess that it's some sort of Monero miner, but we would love to see that, of course. So that's what happened. No big picture. I think this was mentioned as well. We do incident response and not always at like clients that do, I guess, take all the security measures, and we can see there that sometimes they don't have an idea of what all the different AWS accounts are, what the contact persons are, what's normal, what's not normal, which is really important when you do an IR and you try to figure out, is that EC2 machine supposed to be running there, etc. And that's the kind of stuff that often goes wrong, no big picture. No idea what the AWS accounts were used for, but also security teams without the right access. So, well, I would give a tip for the security reference architecture from AWS, which explains in a lot of detail how you should do this. Most companies don't follow this. Jumping the gun. So what happened is they figured out from the AWS mention, well, something is wrong. They started removing VMs, etc. But because they had this nasty IAM policy or the IAM role, even without IAM users, etc., they could still get in. So I cannot share the logs from CloudTrail, but it's really interesting to see. You can actually see in the CloudTrail logs like deletion of stuff. 2 minutes later, the attacker comes in, creates a new one. And it's like almost like a war in the logging, which is, well, I like that stuff, but it's not great. Suspending, so if you have Kubernetes and you have auto scaling, etc., if you start pausing or suspending machines, they might be automatically terminated, and at that point you also lose all your evidence, which is kind of difficult. Some response tips, so what we do in the cloud, I guess, in AWS. Athena is by far, I'm again not getting paid by AWS, definitely not, but it's amazing for instant response. If you have an S3 bucket with some logs, just use Athena. Within 30 seconds, I think you can grab the logs and search them in Athena. Just point them to the bucket, say it's CloudTrail or VPC flow logs. There's already definitions in Athena for that, and it will work. It's really good. Try it out. Do what Amazon does, so use their isolation policies. So if an IAM user, isolate. If you have an EC2 machine, isolate. Just do what they do. They know sort of what they're doing, so yeah, why not? Budget quota, so this is like my favorite early warning thing that almost no one is doing. Set up alerts for your spending. If you're all of a sudden spending 50% more in a month or in a week, why are you doing that? It's like a nice little way of figuring out, well, maybe someone is spinning up really expensive things without approval, I would say. IAM Access Analyzer is really useful if you have a lot of IAM roles. You can use this to figure out quickly what are sort of dangerous roles that allow external access. So IAM Access Analyzer is nice for that. Central log collection is a very basic thing, but it was mentioned in the WIS talk as well for IR. Central log collection is everything. If you do IR, we need to have logs. If there's no logs, it's very difficult to investigate. Luckily, CloudTrail is always there for 90 days, but ideally, you have it in a centralized location. I'm going to go a little bit quicker. Please make snapshots, really helpful. Security people love them, and I will love it as well. What we do during IR is often enable premium logging. So for the time being, we'll just enable everything we can, so we have visibility in VPC flow logs, data access log, etc. It's going to be really helpful. If it's too expensive, you can disable it later. Last one, do's and don'ts. Do write blogs. Keep in mind, AWS is reading everything. I found it to be very intimidating that they read my stuff. They send me emails like, we'll leave it at that. No further comments. And also, don't leave instant response to your IT provider. They are very good maybe at managing your AWS accounts, but maybe less specialized in IR. So they might remove stuff that you really need for your instant response. So be careful with that. Don't blame the developers for long-term access keys. Figure out something better as a company. It's not their fault. If you make it possible, they will use it. Central log management. One little tip. Cloud billing is awesome for data exfiltration. So if you don't have data access logs for your S3, because if you exfiltrate data from S3, it's going to incur egress charges. It's going to turn up in your billing. So little tip, I've found some stuff there. Maybe you find it as well. Last but not least, most important, the sales pitch. Now, if you ever need help with Cloud Instant Response, do reach out. I would love to help. If not, best of luck, and this is everything I have for you. Thank you.
Thank you. It's the last talk of the night. We can keep going. Let's get some questions here.
Great talk. I read your blog when it came out, and it was fantastic. My thought on the RDS part was that they wanted to see if they could find anything useful and then look at the snapshots to create a copy and exfil it. But my actual question is, at the time of writing, I know you referenced like Datadog writing something similar about overlapping like ASNs. Do you ever plan to work with anybody to try to get attribution on some of these things to like figure out who the TA is?
So I had a do or a don't in there that I removed because I tried to be nice about threat intelligence in the cloud, and I think it's one of the. I'm not a big fan right now of the state of it, and I think people are just they're just categorizing it as unknown or putting it in stuff that I'm not sure that even belongs together. It's interesting to see. One thing is that in the previous talk from Sysdig, they also mentioned the Indonesian IPs. Somehow there's a lot of activity coming from Indonesia. It's a great place, I've been there. I'm not sure what the deal is with AWS, but maybe hacking from Bali is really nice. So, I don't know. That's all my... To answer a serious part is I work with everyone. So if people reach out, they want to see some data that I can share or some indicators, I always do that if I can, if my client allows it. So the answer is yes. But threat intel in the cloud and me is not a great match at this moment in time. But maybe it will be better in the future.
I like your theory about Bali just being lovely.
Yeah, I
like
think so
that.
too.
Yeah, you got another question here.
Thank you. This was a fantastic talk. One quick question around your point about using cloud billing APIs and setting anomaly detection, especially from the security team's POV. I would be curious what your findings or your observations are about false positives, just looking at the rest of the company through a billing lens and being able to set reasonable anomaly detection around there.
Awesome. Yeah, it's a very good question. And I must be very honest about where I'm normally coming from. We mostly get engaged when things go wrong. So they rarely want to see me when it goes well. I don't know why, but to answer the billing part, what we do or what we advise is look at the averages from, I don't know, last 12 months across your AWS accounts. So you get at least an idea of what your normal spend is. And then just set it a bit higher than that so that you don't get too many false positives. That's a very pragmatic approach to it, I think. So that's how I would advise that point, yeah. And the cloud billing thing is a bit of a different thing, but that's more from the investigation part, yeah.
Cool. Does anybody have another question for Korstiaan? Going once, going twice? Okay, thank you so much for the talk. Thank you.
Thank you.